Hello, this is the 2009 question 1 uniform acceleration question and solution. Its particles projected vertically upwards from P, and at the same instant a second particle is let fall vertically from Q, and they meet after 2 seconds. So we're dealing with the same time frame, and they have equal speeds when they meet. This is the solution here, solved algebraically with its accompanying marking scheme, but there's other ways to do it. I'm going to show you a way over here which I think is probably more intuitive. I'm going to let Q be the particle that's kind of let fall, and I'm going to let P be a particle that is actually projected upwards. So because the velocities are the same, I can say V is equal to U plus AT. So my velocity for this particle is 0 when I start off my initial velocity, plus acceleration by 2 seconds. So velocity is 19.6. Now I know that this particle here, V is equal to U plus AT as well. I know that 19.6, because that's going to be the same when they meet, is equal to, we don't know it's U. We do know that acceleration is going to be pushing down against this, minus 9.8 by 2 as well. So we're going to get that U is equal to 39.2 meters per second. That's its initial, that's its velocity when it starts off, meters per second. Now we want to prove that these that the distances at PR is equal to 3RQ. So let's just work out what these distances are. So QR, S is equal to UT plus half AT squared. Well, its initial velocity is U and T. So half of acceleration is 9.8 and T squared is 2 seconds. That's 4. So that's going to give me 19.6 meters. That's what the distance QR is, 19.6. Now let's do P. In this case, S is equal to U. Well, U is equal to 39.2. UT, 2 is 2 seconds, T is 2 seconds, plus a half AT squared, plus a half minus 9.8 because gravity is working against it, and T squared is 4. And we're going to get that S is equal to 58.8 meters. So therefore, that implies that PR is equal to 3 times QR. Just an alternative approach over here, which I think is maybe slightly more intuitive than over this side. The second part of the question says that a train accelerates uniformly from rest to a speed of v with a uniform acceleration of f, and then decelerates uniformly to rest with a uniform retardation of 2f. The total distance travelled is d, and draw a speed time graph. There are 10 marks given in this question, probably because when they were doing the marking scheme in the actual test in 2009, a lot of people probably did poorly in this, so they reallocated 5 marks up here, we guess, because it's unlikely to get 10 marks for a speed time graph. However, speed time graph, do make sure you put in the names on the axis, the time and the speed. Identify T1, T2. Here's what I would think is ideal. Identify F as the acceleration here, 2F is deceleration. I put in my little dotted line in T1 and T2 for my times, my velocity, and then label them as well. So there you go, 10 marks of that. Part 2, if the average speed of the train for the whole journey is d over 3, root d over 3, find the value for f. Again, I'm going to show a slightly different way of doing this. Do have a look at this, by the way, make sure you're comfortable with why tan of this alpha is the slope, is the acceleration. The acceleration is not the magnitude of this line, the acceleration is the slope of it. Which is rise over run, which is the slope of the line. So tan of this alpha is rise over run. So that's why tan alpha is the slope. So whenever these questions ask for the average speed of the journey, you're always going to be rearranging your time 1 to be v over f, and time 2 is going to be v over 2f. So let's get that bit done. You can get this from the tan like they did here, or you can get it from v is equal to u plus at. The same reasons you're going to be able to redesign like this. So now my total time t1 plus t2 is equal to, so there's my total time when I add these two up, v over f plus v over 2f, I get 3v over 2f. Now I want to get my total distance, because we're looking for average speed, and average speed, going back to your junior school days, is average speed is equal to distance over time. So let's get our total distance at this stage. Well, distance is equal to half the base by the height, and the base is equal to 3v plus 2f, 3v over 2f, that's the base. And then the height is equal to v. That's going to give me 3v squared over 4f. So that's just, this here is just a rearrangement of this. Now at this point, I think I'm equipped to look at what my average speed is. I'm told that average speed is equal to root d over 3. Root d over 3 is equal to distance over time. And my distance is equal to 3v squared over 4f. And that's going to be divided by, I'm going to use this instead of doing dividing like that, just for the moment, divided by my total time, which is equal to 3v over 2f. Okay, that means I'm going to get 3v squared over 4f times, I'm going to multiply it by now, put this inside bracket, 2f over 3v. So just flip and multiply. And that's going to give me, I'm going to get 12 on the top and, sorry, 6 on the top and 12 on the bottom. So I'm going to get 2 down here. I'm going to have v up here. I'm going to get my 2f is going to cancel out. That's going to give me a 2. My 3 is going to cancel out to 3. My v is going to cancel out this v here. So v over 2 is that. So I've got root d over 3 is equal to v over 2. Okay, I notice, by the way, I have no f in this anymore, but I'll finish this off. I'm going to square both sides. I'm going to get d over 3 is equal to v squared over 4. And that means that the distance is equal to 3v squared over 4. But I have up here that the total distance is equal to 3v squared over 4f. So those two are equal to each other. That means f is equal to 1. And that's your answer. They do it slightly differently here. I would suggest you revise and have a look at this method as well. Now, so whenever you're getting the average speeds, you're going to be converting your times into v over f, your velocity, your final velocity divided by the acceleration. Okay, I hope that helped.